Hi, this video will explain about inhibitors. The learning outcomes are first to define inhibitor, then explain the roles and types of inhibitors which involve competitive inhibitors and non-competitive inhibitors. Then analyze graph related to competitive and non-competitive inhibition. So what is inhibitors? Inhibitors is any molecules that prevent catalyzing reactions when they are bound to the enzyme. So since enzymes is a catalyst, inhibitor will prevent the enzymes to act as a catalyst. The effect of inhibitors, the presence of inhibitors will decrease the rate of enzyme-controlled reactions. The removal of inhibitor will restore the activity of enzyme to normal. Example, malonate or malonic acid, isoleucine, and also ATP. There are two types of inhibitors. The first is competitive inhibitors, and then we have non-competitive inhibitors. Dalam bahasa Melayu, dia sebut perencat bersaing dan juga perencat tidak bersaing. So, what does they compete for? The inhibitors, competitive inhibitors, have a similar shape with the substrate. So, because of its similarity, the shape is similar to the substrate, they can compete, they can bind to the same active site. So, they compete for the same active site. So, when the inhibitor binds to the active site, the substrate will be prevented from binding to the active site. So, enzyme-substrate complex will not form, thus no product will be formed. This will slow down rate of reaction. Instead of taking only a few minutes because of the presence of inhibitors, the reaction needs longer time to finish, to complete. So, let's look at the inhibitor. This is the substrate. Even though we can see that it is not a similar shape, but the site, the parts where it will bind to the active site is similar to the substrate shape. So, since it has a similar shape that can bind to the active site, the inhibitor will fight or will compete with the substrate for the same active site. So, when the collision occurs, the chances of the substrate to bind to the active site, the chances will be reduced. An example of competitive inhibitor is malonate. The succinic acid is the substrate for succinic dehydrogenase. You know the name is succinic dehydrogenase. But when malonic acid is present in the system, it will compete with the succinic acid to bind to the active site. Thus, it will prevent the succinic acid from binding to the active site. So, how can we reduce the activity of inhibitors? How the activity of enzyme can be optimized to lessen the effect of inhibition, meaning that we want to reduce the effect of the competitive inhibitors. Since that they compete for the same active site, so we need to increase the chance of substrate to be able to collide and bind to the active site of enzyme. So in order to increase the chance, we need to increase the concentration of substrates. So when the concentration of substrate is high, substrate will have a greater chance to bind with the active site. Let's look at this graph. This graph shows two processes. First one is process without the inhibitor, and the other, the red line shows the process with competitive inhibitor. As we can see, as the substrate concentration increase, the rate of the enzyme increase. But with the presence of competitive inhibitor, the rate of the reaction at the red line is lower than the rate of reaction of the green line, which is without inhibitor. So at the same concentration of substrate, the rate of reaction with competitive inhibitor is lower than the rate of reaction without inhibitor. But as we increase the substrate concentration, the rate of the concentration will increase. So at the end, the reaction will achieve the same amount of product with the process without inhibitor. The non-competitive inhibitors have different shape to the substrate, so it will not compete. Okay, it will not compete for the same active site because the shape is not similar with the substrate and it can not fit with the active site, the same active site. So the inhibitor will not bind to the active site. Instead, it will bind to the allosteric site. So the binding of this inhibitor, this non-competitive inhibitor to the allosteric site will change the shape of the active site. Even though they did not bind to the active site, but when they bind to the allosteric site, the shape of the enzyme will change, thus change the shape of the active site. So it will prevent substrate from binding to the active site. Enzyme substrate complex do not form, so product will not be produced. This will reduce rate of reaction. Even though we increase the substrate concentration, the rate of reaction will not be affected. Once the non-competitive inhibitor binds to the allosteric site, the shape of the enzyme is changed. The active site shape is changed. So even though we increase the concentration of the substrate, even the substrate will not have any chance to bind to the active site because the conformation, the shape of the active site has already not compatible with the substrate. Okay. So an example of a non-competitive inhibitor is isoleucine. So how can we lessen the effect of non-competitive inhibitors? The only action that we can take is by either removing the inhibitor or decrease the concentration of the inhibitors. We cannot increase the substrate concentration because it is of no use. So what we can do is we reduce the inhibitor in the system or remove. If we can remove it, we remove it. So the graph shows the non-competitive inhibitor will not reach the same amount of the product at the end of the reaction because the enzyme has been changed. So the non-competitive inhibitor will reduce the rate of reaction and also the end product of the reaction. So an increase in substrate concentration will not reduce the effect of the non-competitive inhibitor. An example of non-competitive inhibitors, also the end product that will become the inhibitor when the concentration is too high. So it will, this is a mechanism that regulates the process. Threonine deaminase synthesize isoleucine from threonine. The end product is isoleucine, will then act as an inhibitor to the enzyme itself when the concentration is too high. So, as a summary, competitive inhibitor has a similar shape with substrate, while non-competitive inhibitors do not have a similar shape with substrate. So, competitive inhibitors compete for the same active site, while non-competitive inhibitors do not compete for the same active site. Okay, the example for competitive inhibitors is malonate, while for non-competitive inhibitors is isoleucine. Similarity between competitive and non-competitive inhibitor is both inhibitor bind loosely and temporarily to the enzyme. Okay, this is the differences. These are differences. Malonate is an inhibitor of the enzyme succinate dehydrogenase. How would you determine whether malonate is a competitive or non-competitive inhibitor? So, since the difference between competitive and non-competitive is if we increase the substrate concentration for competitive inhibitors, the increase of substrate concentration will reduce the effect. So, in a way, to determine, we can use the mechanism of increasing the substrate concentration. Thank you.